Today I will present the the eighth research paper analysis. So the title of the paper that I analyze is Prioritizations of Smelly Classes, a two-phase approach reducing refactoring efforts. This paper has been accepted to IEEE through the International Conference on Computational Intelligence and Communication Technology, and the conference was held last February. In terms of how to determine the venue quality, the CICT is not one of the well-known venue. It's not listed as one of the top software engineering conferences, and this paper has a 0 citation count. So as far as the problem statement of the work, frequent change in an object-oriented software system often result in a poor quality and less maintainable design, and this is sometimes called code smell, which cause the degradation and need to be corrected, for which refactoring is one of the possible solutions. So it's not feasible to refactor each and every smelly class due to the various constraints such as time and cost. So for this reason, it's desirable to make an efficient approach of refactoring. So the proposed schema aims to save time and cost of refactoring by carrying out selective refactoring for high priority smelly classes to reduce refactoring efforts. So the basic idea of this paper is to propose a two-phase approach to detect the smelly classes and to prioritize these smelly classes based on their interactions level with the rest of the system. So the project that has been selected to do the experiment is hospital automation with Java EE. They select this project because it has enough numbers of code smells and it's a medium-sized project, so it's easy to understand and explore. And the two phases that is involved in this experiment are detection phase and prioritization phase. So this diagram shows the two-phase methodology for the efficient refactoring. So for the detection phase, the smelly instances are identified using a tool called JDeodorant, and the change history report used for identifying the interactions of a class with the other classes, as this will help indicate the coupling of the class with the rest of the system. So by knowing the interaction of a class, developers can make decisions about the smaller classes that need to be refactored first. So in the prioritization phase, they will mine the change report of the small classes listed in the first phase, and based on the interactions analysis of each small classes with the other classes within the system, the impact analysis is calculated. So the more the impact index is, the more severe a class is. And then the smelly instances are prioritized according to their severity level after mining their change history reports. And lastly, they apply refactoring for the classes listed in the priority list. So this slide shows the result of the experiments. Based on the impact index values obtained, the priority list is formed by arranging the classes in non-decreasing order of the impact index. So refactoring using prioritizations left only 21% code smells in the system. However, the random refactoring, the one that's not prioritized, left 50% code smells in the system. And lastly, refactoring using prioritizations left the system less smelly after each successive refactoring applied. That is not the case with the random refactoring. So some of the suggestions in order to build up the research is to consider other factors that might affect the developer's decision related to fixing smells. For example, the effort needed to fix the smells, the importance of the issues, and using developers' context to provide developers with a list of prioritized um, code smells related to their current context. In addition to that, conducting and reporting the result of the large-scale empirical study over open source projects. As in this study, they use just a medium or just one medium-sized projects. And lastly, considering other code smells that is mostly used in the practice, such as plop and shotgun surgery code smells. So that's all about this research paper analysis, and thank you.